So we know now how to approach data visualization, how to think about data visualization in step-by-step parts. So now we can start with the second part of today's workshop, where I'm going to show you some techniques in TouchDesigner, or rather show you how I approach making data visualizations in TouchDesigner. So let's start from the beginning with the very basics. So like I said, I've used this data set from the MoMA about all the artists in their collection, and I've downloaded it already. And as you can see, it's just a XML, it's just an Excel file. You can open it in Excel and you get this table with information. So we have an artist ID, we have the name of an artist, we have their nationality, their gender, their birth year, and their death year. Some of them not being dead yet, so there's nothing here. You can also see some don't have any information. That's important when creating data visualization. You need to know if there's missing data. Yeah, and like I said, I wanted to find out how many female artists are in MoMA's collection. So for us today, we're mainly going to focus on this gender. So let's open a new TouchDesigner project. Delete all of this, and what I like to do is create a base container and just call it data, and I like to organize all my data inside of here so I know where it is inside the project. So let's first of all use a file in to call our data. So we have our data table over here, and now we need to work with it. So I want to figure out how many artists we have overall. I also want to figure out how many of them are male and how many of them are female, and then also how many of them are not, don't have any data. So first of all, I used multiple select stats for the first one. I'm going to use to select all the male artists. The second one I'm going to use to select out all the female artists. And then the last one I'm going to use to select all the artists that don't have any information. And yeah, like I explained with the select that, we can choose specific rows or columns. So what I did is I'm going to change this select row to by values. And then I want to use pattern matching to select all the male artists. So you can just type in male over here, and you have to select the column that you want to look at. So that column was column number 3. So I put for column from column number 3 in here. And now we have all our male artists in here. But after working with this a little bit, I realized that this data set is not 100% perfect, and I'm not sure if I can find it just by looking in the viewer, but they sometimes wrote male with a small m, not with a capital M. So if I change this to a small m, we can see there's a few data points that the spelling is different. So you can just use a space and then type in male once again with a big M, with a capital M. So you will get all of these both. So with a small m and a capital M, you will get all the data points. And then I did the same for female. So once again, select rows by value. Here they made the same mistake. They wrote female sometimes with a small f, sometimes with a big F. Then I changed it to column 3. So now we have all our female artists in one column. And then for the last column, I wanted to check if there's maybe any misspelling, maybe just no data, or maybe something written completely different. So what I did is I'm using this. Where is it? This symbol. And then I'm just gonna write female. And again, with a capital F. And then do the same for male. So it will ignore all the rows that have female, male written in them. And we are left with, sorry, change this to column 3. And we are left with this empty row of gender and the artists accordingly. So yeah, now I've divided my data into the 3 data points that are most important. And now I was like, okay, how am I gonna visualize this? I have no idea what I'm gonna do with this. So I just started trying different things, whatever came to my mind in my head. And I feel like that's really important working with data visualization. Just experiment with the data, try different visualizations so you can find what works best. So I created a container outside my database, and I'm gonna split my viewer into 2 and go back to my data. And then I'm gonna use a select dash. Oh, each of these. So at this stage, I'm not really caring about efficiency or having my visual optimized to run it like 60 FPS. I'm just experimenting with the data and trying to figure out some way to visualize my data. So it's okay if you're just playing around, making lots of copies. don't worry about it. We can always optimize later. So the easiest way I could think about is using a text stat. So a text top. So I used a text top and I wrote here, artist. And I'm copying it. Then I wrote the artist. And then this text stat desktop has this post text parameter, so you can add something after the text that you wrote. And I just used some Python script so I can figure out how many rows we have in this table, in these tables, because these rows are going to correspond to how many artists are in this data set, like how many male artists there are, how many female artists there are, and how many of which we don't know. So let me write an expression in here. Before that, maybe let me zoom in a little bit so you can see better. Right off. I think that's what I changed the operator name to. Yep. And then use these squared brackets. No, wait. And then I wrote that num rows. And for the post text, you would probably have to click on the name and change the type it's using, the format it's using. How do you call this? You can change between expression mode, export mode, and binding mode, or just using constant values. So I'm going to change it into expression mode. And as you can see, we have 9,826. Oops. I'm going to zoom out again. Data points or rows in our table for male. And to see this a little bit better, I'm going to add some blank space in front, like this. Reize is not working. Let me check.
Maybe you need a string. You need to make it string.
Yeah, I think so. That's what I did.
Oh, yeah.
Yeah, that worked. And then, yeah, I just reduced the text size a little bit, maybe 16. And then I can do the same for the other text stats. You can just copy and paste what we wrote over here, but change the operator name to female this time. And again, change the mode. And also change the text size, font size. And then for unknown, we have in here, as you can see, our first like header row. And we could always just use a -1 behind this string and remove one of the columns. But I feel like I'm going to use the same data, the same table, probably over and over, creating other visualizations. So I went back to my base and I put into this row select values also gender. So we remove the first header row from this table and just have more uniformity in the way we're working with when creating our visualization. So I'm gonna copy this again in here, and also gonna change the operator name to unknown. I could type. And then also change the font size. So now I have pretty much the data that I want. I have male artists, 9,826, female 2,193, and unknown is 3,072. But this is not a data visualization really. I mean, you could say it is, but it's very boring and it's not really doing its job that great. So I was thinking, okay, how can I make this more interesting? What would be a great way to visualize this data? And I figured out this kind of test, really simple test you can do with just very simple circle tops to figure out a great way to visualize your data. So we're going to do that next. But before, what I did is I went back to my database and I created a new table. Because we're probably going to use these numbers over and over again in our project. So I just wrote them in a table, made a new table, and you can just make the viewer active and then write your own text. And if you right click on here, you can add more rows or more columns. So I'm just gonna type in my data over here so I can use it later anywhere in this project. Female. You can also delete rows again by right clicking on them. And then I also thought, okay, we're gonna need another column with all artists. So the total of amount of data points we have, so we can actually compare these numbers to something. So you can do this in multiple ways. We can just use the rows function again, but we can also look at the last row number over here. So 15091, but yeah, that's correct, because 0 is our first header row. No, wait. We have to remove 1 because 0 is our header row. So and then, yeah, so we can use this table now pretty much anywhere in our project. So what I also thought is, okay, it's gonna be, since these are really huge numbers that are kind of hard to read, kind of hard to grasp any idea of what it, getting a grasp of how much that is, it would be great to change these amounts to something more normalized. So for example, thinking about it in percentage, like 100%, 50%, how much percent is it? Or also normalizing these numbers down to a value from 0 to 1, or any other value. So I'm going to use the evaluate that and put the first input, table 1, into my first input. And then I'm going to create another table. And in here, I'm going to mirror the structure of the first table. But then I'm going to use some Python and some math expressions to create our analysis. So first of all, I want to keep the first row with my labels. So you can use, let me check. I'm kind of losing concentration, sorry. Yes, that's what I want. me.input cell, and also me.input cell for all the other columns. And then let's say we want to figure out the percentage. We can use, since all artists is over here, I'm going to type into column number 3. We can do me.input cell divided by me.input cell, and then put it into brackets, and then times 100, which will create 100%, because we're dividing all artists by all the artists itself. And then you have to repeat the step for all the others as well, but divided by not itself, but the amount of all artists we have. So now we have a percentage of artists. So 65% are male, 14.5% are female, and like 20% are unknown out of 100. But then, like I said, I probably want to use all of these information all over again, like all the time again. So I try to organize this in a way that I can have all of these values and maybe even more values in one table. So let me show you what I did. I created this table with the label sex for the gender. So all female, male, unknown. And then we have our pure number. And then I also said, okay, I'm going to use percentage of 100, also normalized to 1, and also normalized to 0.5. And I also put percentage of 360, but I actually didn't end up using this. So let's recreate this. So I created, could use an insert as well, but I just made another table with multiple rows. So we have sex in our first row, and then set pure number, and then percentage 100, and then also normalized 1, and then normalized 0.5, and then delete this. We don't really need this. And then I merge these together with a merge that. Using append columns. So we have a similar structure to what I showed you just now, earlier. And we can use this instead of our table 1 over here and put it into our eval. And then we can write more of these math equations according to the data that we want. So the first column we have to change to me.input cell, because we're going to use the first column for more labels. And then I want to keep inside the first row the original data that I have. So let's add some more rows. We need in total 4. Let's move this, copy this down here, and then change this to me.input cell. And then let's copy me.input cell to all the other rows in here too. That times 100. And over here in 4 too. And then in this column first, column 2. And then, yeah, we need meter input cell divided by what we already did for our percentage 100, and we need that in this row completely. And then for the second, I want to normalize this to 1. So I can just remove this times, if I'm correct. This times 100. And then for the last one, I want to do times 0.5 for all of these. And this should work. Why do I have an arrow? I'm stupid. I shouldn't use me input cell over here because there's nothing in the cell to create our to do our math on. So we need to actually specify the row and column that we want. So I can use Python for that again and write in here we can write in here op merge 1, but we could also just take these and copy these to all of the other columns, whatever you think is faster. I'm just gonna use my Python. So change this first one to op 1, and then we're gonna use column 1, row 1. This doesn't belong here. This belongs behind here. And then you can copy this part and put it in or over here, but change the row to row number 2. And then the same for the next. And then over here as well. So you can see we have our percentages again. And then we also have to do the same for everything else. And over here too. Change the 2. Change to 3. And 4. And once again, I made a spelling mistake over here. So yeah, now we have our original data and then our percentage, like 100%. Then we also have the normalized value, normalized to 1, and also to 0.5. And then I'm just gonna add a Now behind this, you can call this final data. Now we can reference this table whenever we're working on data visualization. So let me split my view again. And then create a new container. And like I said, I figured out some way to kind of test the best way to represent our data visually. So what I did is, first of all, let me delete this and create a new select. We can close this now. And then just use a circle top. So I'm gonna just create 4 circles for which we can compare for each of our data points. And I'm gonna use this normalized to 0.5 value to change the radius of the circle. So we can check if size is a great way to represent the data. So let's do that. And the reason I'm using the normalized to 0.5 is because our radius, as you can see, the biggest is 0.5. And if we go over 0.5, our circle will be bigger than the texture that we have. So I'm using that. So let's start with circle 1. And again, use some Python expression to call our data. So up again, and this time select 1. Then it's column 3. And I'm gonna go with all artists at first. So row number 4. Sorry, not column 3, column 4. And copy this and paste to our radius Y as well. So these are 100%. And then for circle 2, I'm gonna use male at first. So I'm gonna change this to row 1. The same for radius Y. And then circle 3, let's do same, but use female now. So change the row to number 2. And then lastly, we're going to use unknown, which is row number 3. And just looking at it like this, we can already kind of see the difference in size. But I also want to check what would happen if we visualize this with color. So I'm going to use the normalized 1 value in our fill color RGB values. So same with the radius. I'm just referencing this table. This time really column number 3. And we need row number 4 because I have the wrong operator selected. Circle 1. Circle 1 for row number 3. And then do the same for G and B as well, which will create white because it's 1. The value is 1. But if we do this, for example, the male data, so circle number 2, let's change this to 2, and then change G and B, we will get a gray value. And then actually this needs to be 1. I'm sorry, it's a little bit confusing. So we will get this gray value. And if we repeat the same for circle number 3, this time actually with row 2, we get another gray value. So we can later just combine all of these into one layer, merge all of these into one layer, and use a lookup to change this gray to whatever color we want. So let's do this for the last circle as well, which is row 3 and column 3. This one. And then I made a constant. And I'm gonna make this size 4 times our original resolution we're using. So I'm just gonna write times 4 over here. And then maybe change the background color to black. And then use a composite. In add mode, and on the transform page, I'm gonna change fixed layer to input 1, and then prefit overlay to native resolution. And then I'm gonna move this a little bit to this corner over here. And I'm gonna repeat this step and also arrange the other circles on here. Change the position a little bit. So this circle goes over here. And then again, time our circle should go over here. Once more. Is my point invisible? Oh. I needed to change this to minus, so it's over here. So we have our 4 points with our data, which have different sizes because of our data, and they also have different gray values because of our data. And then let's use a lookup and wrap top. So we can change this color to just something random. Maybe I'm going to use red over here and then going to maybe blue. And this doesn't have to be beautiful at this stage. It's just kind of my way to figure out a way to visualize this data. So just cleaning it up a little bit, but yeah, as you can see, the size is quite different of these. The color, these both are not that easy to distinguish. Actually, size is also quite similar, but still, color is even harder to distinguish than size. So if we use color, it's maybe better to use color as a label instead of representing different amounts of data with color. But I guess size would be okay to use with this data set. So it's kind of a small experiment that I kind of like doing at first with the data to figure out how can I encode this data best. So after that, my idea was, okay, let's create maybe a simple bar graph. So let's make another container. We can delete all these tops, but don't delete the select. And then I just used a rectangle top. And on this rectangle top, there is this justify horizontal and vertical parameters. So usually it's set to center, but we can also set it to bottom. So our box will start growing from the bottom. And then I'm also going to change its size to 1. So with this, we can just easily create a bar graph, right? So let's copy this 4 times. And it's best if you rename your operators to what data you're showing with it, so you can easily identify what you're doing again. So I'm this time going to change all of these. So first of all, I'm going to change this to all, and then male, and then male, maybe. And again, I can just reference this size Y from our table that we made earlier with our normalized values. So this time, again, we can pretty much the same process. Just type in the operator name, select 1, choose our rows and columns. You can actually also write the name like this. It needs to be other way around. Or not. Maybe I just missed. Nope. Must be string. No, that should not be wrong. Maybe I don't need these. No. Huh. I wanted to be smart and show you that you can actually reference by name as well, but I don't usually do that. So let's just use the index to reference again. Up select one, and then four and 3. Sorry. 3 and 4. I'm confusing myself with trying something. Okay. Then let's repeat this for the other ones as well. So row number 1, column number 1, and then for female, it's number 3 for others. So we have our bars, and then we can again use a constant. Like this maybe 1280 by 1280. And again, change the background to maybe black. Then again, just composite these together, just like we did with the circles. But this time, just gonna move a little bit, maybe 0.2. Zero. And this one maybe minus 0.2. So you can already kind of see that it looks like a bar graph. And then maybe we don't need the rectangle all, because we all know a bar graph's like full percentage should be right 100, right? So maybe let's remove the all, and then these just one step down. Like this. Let's create a null at the end so we can see what we're doing. So yeah, this kind of looks like a bar graph already. We just need now context, right? So we can figure out what we're looking at. So what I did, before was I created a user text stat to put in my question, and then I changed these colors to something that maybe works in encoding this visual. So as I'm using this color as a label, not to actually show like difference in the data. So pink for female, blue for male, very stereotypical, and purple for unknown. And then I also put the labels in text down here, plus percentages. And then I also made this small artist data set, MoMA visualization by me. So let's just maybe not do all of this, but look at how I used the text, how I made this text and this text over here. So let's create a text, and then you can just type in here. And then we can turn on word wrap. And I know it's best to usually just make these textures the size of the text that you actually want it to be. But sometimes I find it difficult to create beautiful text just by looking at a small texture. I kind of need to have the feel of what the canvas actually will be, what the size will actually be like. So sometimes I just change the resolution to my actual canvas size over here. Yeah, and then we can just composite this again. And then you can move the text over here with these position parameters, or also with the transform translate parameters. Or what I find is easiest, just use these align parameters. So horizontal align, left or center or right, I'm going to use left. And then vertical align, I'm going to put it at the top. And then you can just create some borders, maybe 150. So it doesn't stick to the very top left. Maybe you can even make it a little bit more. And then we can play around with the text size and the style. I think this is not something new to you guys. So changing this font to something beautiful is definitely gonna improve what this data is gonna look like. I kind of like fonts like IBM Plex or Bahnschrift or Rockwell, I think looks really nice with this data viz. And then we can do something similar with this time change the tags to our labels. So male 15%, other no 20%, and then male was 65%, if I'm correct. Yeah, probably. And then composite it again. Add, this time change the alignment to center and maybe bottom. Maybe move it up over here under our bars. Change the font size a little bit. Maybe put some white space between these. To make it fit a little bit more. So yeah, and then we just need to change maybe the color to identify each bar with the data, with the label down here. So our male rectangle, we can just change the fill color to maybe blue. You can use any other color, but usually when we think about boy colors, it's blue. Then female colors, usually we think about pink. And then rectangle others, I just put purple because it's in between. And right now my labels are actually in the wrong order. So let me change that. Match my data better, so it's a little bit more easy to understand. So yeah, you can work more on this to make this look more beautiful, but I'm just gonna stop here.